congratulations. You just finished writing the practicals for physics. Right now we are focusing on mathematics and physics theory, okay, and the objective questions. So our mission right now is to ensure that we dig deep and we dissolve all the necessary parts that are involved in theory, in the theory part of our examination. You all know that NECO has its own pattern of setting exam questions. The first question here is explain the term forbidding gap. Explain the term forbidding gap. Now, in every semiconductor, there are two bands. We have the valence band and the conduction band. So between these two, there is a gap between them. That gap is known as the forbidding gap. Okay, it is a barrier, and if an electron can overcome that barrier, then that electron changes from the valence band to the conduction band and become a conducting electron. So that is what forbidding gap is. So forbidding gap is the energy barrier, okay, that the valence electron must overcome to become a conducting electron. So that is question number one. Now question number two. What are the charge carriers and holes? These are the two charge carriers in semiconductors. Okay? Question 3. What are donor impurities? So what are donor impurities? Now, donor impurities are atoms that have 5 electrons in their valence shell that are used for doping semiconductors. Usually intrinsic semiconductors. So you dope intrinsic semiconductors. When you dope intrinsic semiconductors, then you have what's called the extrinsic semiconductor. So what do you use to dope intrinsic semiconductors? There are two types of impurities that you need to add to the pure semiconductor, okay, to give you the intrinsic semiconductor or the extrinsic semiconductor rather. Okay, what are these two? We have the pentavalent element. The pentavalent element has 5 electrons, okay, in their valence shell. Pentavalent. Penta means 5. Valence means valency. Okay, pentavalent. Alright, pentavalent means 5 valence electrons. So there is 1 extra electron. It has 5 electrons. Then we also have the trivalent. Tri means trivalent. So tri means 3. Okay? Tri means what? 3. So when you use trivalent, there is a shortage of electron. Okay? There is a vacant place to be filled by electron. But when you use pentavalent electron, and when you add pentavalent electron to the intrinsic semiconductor, you have an extra electron. So that extra electron is what makes the extrinsic semiconductor to be n-type. This one gives us what? N-type. N-type. When you dope with pentavalent, you get n-type due to extra electron. Okay? While this one gives us what you call the p-type. Okay? The p-type. Right? Due to the presence of what? Holes. Okay? That's why we have this. So, and these pentavalent electrons are called donor impurities. They are called donor impurities. Please don't forget, they are called donor impurities. Donor impurities. Alright? While these ones are called donor impurities, while the trivalents are called acceptor impurities. Acceptor impurities. Please don't forget that, okay? Acceptor impurities. So these are the two types of impurities that are added to a pure semiconductor, okay, to give us the n-type or the p-type semiconductor. Please don't forget. Then what is energy band diagram? Okay, draw the energy band diagram. Now in the energy band diagram, we are going to have the forbidding gap. Okay, so let's quickly sketch the energy band diagram. So this is the valence band. Valence band. Then here is the conduction band. Conduction band. Okay? Conduction band. Alright? Here we have so many energy levels. These are energy levels. Alright? There are energy levels here. Alright, this is just one of the energy levels. Okay? So if I valence an electron here, which is a valence electron, jumps from here to here, it has to overcome this boundary. So this boundary, this is called the forbidden gap that I told you initially. Okay? So that is question number 4 now, used to explain forbidden gap. Alright? Then number 5, properties. Mention 2 properties. Okay, that's number 5. Okay, state 3 properties of an intrinsic semiconductor. Intrinsic properties of an intrinsic what? Semiconductor. State 3 properties of an intrinsic semiconductor. When we say intrinsic, we mean pure. Pure intrinsic semiconductor. They are pure semiconductor, okay? They are pure. 1, they are pure. 2, they have low conductivity. Alright? So that is 2. Then there are many of them, okay? They are pure. They have low conductivity. Alright? Then the number of holes is equal to the number of what? Electrons. They have equal number of holes and electrons. So that is number 5. Number 6, please don't forget we are preparing for NECO examination, the theory and the what? The theory and the objective. Alright? Then number 6. Now we have 2 output characteristics. The output characteristics of 2 diodes, A and B, are illustrated in the diagram below. So look at these output characteristics. We have one here and one here. Alright? This one goes like this, while this one stops here. This is O, this is our O. Alright? Here is our minus V stroke V. Here is our minus V stroke V. Here is our plus V, which is V stroke BV. And here is our small v stroke BV. Okay? Here is our A, which is in ampere. Here is our minus I. Here is minus I, which is in ampere. Do the same here. I in A positive, while here is the minus, which is also A positive. You can see this. This is diode A, this is diode A, and this is diode B. Diode B. Then they said out of this diode B, which one is an ID rectifier? Which one indicates ID what? Which one is an ID rectifier? Alright? Now the question is, at this point, you see there's no current. This is current, okay? There's no current here. But this is showing current and current. This is forward bias. This is backward bias, okay? Forward bias, reverse bias, okay? This place is a backward. This is forward bias. This is reverse bias. Alright? So in forward bias, there is a flow of current. You can see it here. But in reverse bias, there is no flow of current. So that process is what you call rectification. To rectify a current means to make it flow in one direction. So you can see that the current flows here, but does not flow in this direction. But this one is showing both sides, so which is wrong. So this one, diode B, is the ID what? Rectifier. Okay, they say which of them is an ID rectifier. To rectify a current means to make it flow in one direction. So that is what it represents. Okay, so the ID rectifier is diode B and not diode A. Okay, please take note of that. So let's quickly go to the next question. The next question is, what is PN junction? Now, I told you we have the N-type. Okay, we have the N-type semiconductor and the what? And the P-type semiconductor, right? The N-type semiconductor and the P-type semiconductor. Alright? If this is the if this is the N semiconductor and this is the, if this is the P-type, let's say this is the P-type and this is the N. If you join them together, the junction where they meet, the junction is the PN junction. Okay? The barrier between the two is called the PN junction. So let's assume that we now join them together. You join them together, okay? We join them together here. So this is P and this is N. So this junction here is called PN junction. Alright? PN junction. So PN junction is used for making diode and other materialized transistor, okay, thermistor, and so on. So, and diodes are used for rectifying current and for transmitting signals. Alright? So this is where we end the class of today. I hope you have gained so much. Please smash the subscribe button if you have not subscribed, and also turn on the notification bell as well. Then you can share this video, like and share the video to those who are preparing for NECO. Alright? I can assure you, with all these things I'm doing from now on, okay? It's going to be day by day. Alright? You'll be receiving it from Monday to Saturday until the day you write your exam. We will keep doing it. Alright? Please do well to let others know about this. Alright? On the post, I gave you how we are going to go about that. Alright? So thank you very much for listening. I wish you success as the theory and objective comes by. You are a success. Thank you very much and goodbye for now.